All right, Ozarka again. This is going to be a video on algebraic operations on functions. So what we're basically going to be doing is computing the sums, differences, products, and quotients of functions. So adding, subtracting, multiplying, and dividing of functions. We're going to also be computing what's called a composition of functions. So this is when you have a function of another function, or a function is inside of another function. Next thing is we're going to write a function as a composite of functions, and we're also going to be solving problems involving operations on functions. All right, the first thing that we're going to look at is combining functions. It says besides transforming individual functions, that was in the previous video, two or more functions can be combined in a lot of ways to produce new functions. The most basic combinations of functions come from the four basic arithmetic operations, mainly adding, subtracting, multiplying, and dividing. Just like always, whenever you're dividing, you have to make sure that you are not dividing by zero. So if you notice right here, this one's dividing the f function by the g function here. G cannot be equal to 0 because you are not allowed to divide by 0. I'll show you some examples where this comes into play. All right, let's look at some examples. It says, given the following table of values, compute f plus g of 2, f minus g of 3, and f times g of 1. So to do this, I'm going to break this down like so. The first one, f plus g of 2, is basically going to be f of 2 plus g of 2. We're going to use f of 2 right here. There's f, there's 2, and where they intersect, f of 2 is equal to 10. And we're going to add it to g of 2. Here's g, here's 2, and we're going to add it to negative 2. 10 plus negative 2 is going to be 8, and that's our first answer. The next one we're going to do is f of 3 minus g of 3. F of 3, here's f, here's 3, where it meets is negative 8, so it's going to be negative 8, minus g of 3, here's g, here's 3 again, it's going to be equal to negative 10. Simplify this out a little bit, the minus minus to a plus plus, and you end up with 2 as your answer. All right, the last one, it says f of 1 times g of 1. One thing I do want you to notice is the way it's written, I kind of rewrite it so it's a little bit easier to understand, okay? The top part is basically the shorthand way of writing it. The bottom part, the way I'm writing it, is kind of the longer way, but it helps with solving it. Try to organize your thoughts that way. All right, f of 1 is negative 3, so I'm going to put a negative 3 in there, times g of 1 is 7. Put a 7 in there, and you end up with negative 21 for your answer. All right, for the next example, the functions themselves, f and g, are defined by equations this time, where the other problem that we just did, f and g were just in a table. Okay? It's the same kind of thing. You're just going to have to do a little bit more work to find those values. So this newest example, it says compute f divided by g of 2, which is just f of 2 divided by g of 2. So I'm actually going to write that down. So f of 2 divided by g of 2. So what we're going to do is we're going to plug in 2 to this top function right here, this f, to find f of 2. So you're going to get 4 minus 14, which is negative 10, plus 1 is negative 9, so I'm going to put a negative 9 in there. Then I'm going to plug a 2 into this g function to find the g of 2 part on the bottom, which is just 2 to the third, which is going to be 8. So the answer for this one, the f of 2 divided by g of 2, is just going to be negative 9 over 8. This next one is going to be a little bit different. It's going to be f of 0 divided by g of 0. Now, right away, you should be able to see that g of 0 is going to be equal to 0, okay? If you plug a 0 in qubit, you plug a 0 into the g of x function, and it's just going to be x cubed, so 0 cubed, you're going to get 0. So by dividing by 0, your answer is automatically going to be undefined. It does not matter what f of 0 is. In this case, f of 0 is 1. I could put that in there for fun, but you're dividing by 0, so it's undefined. So f of 0 divided by g of 0 is just going to be undefined. All right, now let's look at composite functions. Now with composite functions, it's not multiplying, it's not dividing, it's not adding or subtracting. It's literally the function goes in as input to the other function. So this first one right here, it says, what is f of g? That's how it's pronounced, f of g. That's the shorthand way of writing it. The longer way of writing it is f of g of x. And I kind of over-exaggerated the parentheses to kind of show you that g of x is the new input of f. So f of x is equal to x squared minus 5x. Well, f of g of x is going to be equal to g squared minus 5g. Essentially, all we did is the x got replaced with a g, so this x and this x got replaced with a g as well. So I want you to kind of see that symmetry there. Instead of f of x equals x squared minus 5x, it's f of g of x equals g squared minus 5g. So the x is just turned into g's essentially. Now we know what g is based on this function right here. It's equal to x cubed. So what I'm going to do is just put x cubed in for all these g's. Okay, I'm going to simplify this out, and you're going to get x to the 6th minus 5x cubed, and that's your final answer. If you notice, I did not do f times g, I actually put g in as the input for f to get this function. Now, f of g of x is not the same as g of f of x. I mean, it could be, but in this case, it's not. G of f of x is going to be, now g is the outside function, the inside function that goes into g is f. So now we're going to replace all the x's in the g of x equation with an f. So instead of x cubed, it's going to be f cubed. Well, what's f? F is x squared minus 5x, so now it's just going to be x squared minus 5x quantity cubed. Now you can expand this out if you want. We are not going to do that though, because it's just kind of a waste of time. We're just going to leave it like that. And that's the answer. All right, the next one, f of x. Okay, it's another interesting thing about composite functions. You can put a composite function, you can make a composite function where the function is being thrown into itself. So f of x is just going to be f squared minus 5 times f. So you can kind of notice it's similar to this one up here, where instead of it's f of g of x, but all the g's, all the x's turn into g's. On the bottom one, that one that I just did down here, now they all just turn into f's. So you can hopefully see the symmetry with those two. All right, now from here, I'm going to replace all the f's with the x squared minus 5x. So it's going to be x squared minus 5x quantity squared. I'm not going to expand that out as well. Minus 5 times f, which is just going to be x squared minus 5x. So I'm just going to put 5 squared, or x squared minus 5x, something like that. And I'm just going to expand, I'm going to distribute that second part. I'm not going to expand this part though, we don't really need to. Doesn't make the problem any neater to look at. Plus 25x. So we'll just kind of stop there. You'll notice in your calculus class that you can actually leave your answers like this as well. So it makes sense that we do it in pre-calc. All right, the next one, it says refer to the table above. It's the same table that we were looking at before, and it says find f of g of 0. All right, so I'm going to rewrite that in the long way. So it's going to be f of g of 0. Okay, and just like before, we're going to find out what this value is first. So g of 0 is going to be 2. So this is essentially equal to f of 2, because this part right here is equal to 2. F of 2 is right here, is 10, so the answer for this one is just going to be 10. Onward we go. The next one, it says let g of x equal to the square root of 5x plus 25, and h of x equal to x minus 4. Find g of h of x and then determine its domain. So if you remember the domain with square roots, namely, is you cannot do the square root of a negative, otherwise you get an imaginary number. So we're going to deal with that for this one. And also another important domain is you can't divide by 0, but we don't really need to worry about it for this one. So g of h of x, so g of h of x, I'm going to write it the long way, looks something like that. And we're going to replace all the x's with h. So it's going to be 5h plus 25, and we're doing the square root of that. 5 times x minus 4, because h is equal to x minus 4, so I basically just substituted that in, plus 25, and we'll do the square root of that. Okay, this is going to be equal to 5x minus 20 plus 25, square root that. Okay, and then we just have to simplify it, and you should get 5x plus 5. The square root of that. So that's the first part of it. It says find g of h of x. That's what this is right here. Now it says determine the domain. You cannot do the square root of a negative. Okay, so that means that 5x plus 5 has to be greater than or equal to 0. So we're basically just going to solve this out. We're going to divide both sides by 5. 0 divided by 5 is still 0. And subtract 1 on both sides, and you end up with x is greater than or equal to negative 1. If you want to write that in interval notation, which is not a bad idea, negative 1 comma infinity. Make sure you have the brackets around the negative 1, because you can technically be equal to negative 1 there, and you're not violating any domain restriction. All right, for this last one, we have f of g of x, and we have a couple of rational functions here, so this is going to be pretty interesting. Let's start by writing it in the long form. So f of g of x is going to be equal to 2 divided by g plus 3. I'm going to substitute the g in there, and you're going to get 1 over x minus 2 plus 3. And it says completely simplify it. Okay, as you can see, it's not really looking very good right now. So we're going to multiply the top and the bottom by x minus 2. All right, from here, we're going to further simplify it. So it's going to be 2x minus 4, and then we're dividing it by 1 plus 3x minus 6. And then we can further simplify that to be 2x minus 4 over 3x minus 5. And that is our final answer for the first part. The next part, it says, what is the domain of the composition? First thing I'm going to do is look at this denominator here, because this is the main thing you want to look at. You cannot divide by 0. So basically it means that g plus 3 cannot equal 0. So in order for this to be equal to 0, g cannot be equal to negative 3. So in order to account for this, I'm going to plug in g over here. It's going to be 1 over x minus 2 cannot be equal to negative 3. I'm going to multiply both sides by x minus 2. I'm going to solve this out, minusing 6 on both sides. And you end up with x cannot be equal to 5/3, which is the same thing as if I did this over here. So it probably would have just been easier if I just solved this as not equal to 0. You get the same answer either way. Another important part is you cannot have any denominator equal to 0, including this one right here. So you also have to count for this one right here. X cannot be equal to 2 because it would cause a division by 0 in that g. So the domain for this would just be x cannot be equal to 2 or 5/3. Essentially, that's the final answer for that one. So that's a video on the algebraic operations on functions. If you have any questions about anything in this video, let me know.